right, everybody, welcome out to the Takt Towers game. This was a game that was invented by Lean Communications in Norway. It's a really great a game, and what it is symbolizing here is that this is a building with different rooms, and each of these humans down here are trade partners. So you'll see concrete, mason, carpenter, plumber, electrician, carpenter 2, and painter. We've got to get all of these humans through this building here, and we need to do it as efficiently as possible. So let me show you how the game works. So if it says, a contractor is going to do 1 unit, then this is a unit. They'll start here, they'll exit here. And these ranges down here at the bottom, the ranges symbolize a roll of the dice by the computer. It's a random roll of the dice by the computer. And so if I do a 1 to 6, that means that this trade partner can go really fast, but by virtue of going really fast, they can also go really slow. So 1 to 6 is a highly variable environment. When you play the game, if you hit start game, you know that this first concrete contractor is going to roll. If I hit start rolling, the computer will randomly select, just like a roll of a dice, a 4. That means she can come in here and do 4 units of work. And when you click on that, you can see that she comes in and does those 4 units of work and completes. Super excited, right? If you hit end round, that means that she is done, and 4 units for concrete are done. Now, if you hit start round 2, you'll see that 2 contractors are up. I can hit start rolling, and you'll see that the computer said that concrete can do 4 and the mason can do 2. And when we hit start building, the concrete contractor, she should be pretty happy and go forward and accomplish her work. But you'll see that the mason wanted to do more, but she didn't have enough people. She needed more personnel, right? So you can kind of get an idea of how this works. Let me put this on autoplay, and you can see how they work through. Anytime you see the question mark, that means that a trade has slowed down and that there's a little bit of difficulty, but as they're going through, right, they're trying to get complete as fast as they can, and you'll see that they're done here on the left as they move through the building. But at the end of this, you'll see the results, which I think are pretty interesting. So on this one, you'll see that by the time they're done, the painter finished on week 16 with 202 people on site with an unused capacity of 34. And you can see their little intended tack line here had a lot of variation, okay? Let's play this one more time with the same parameters, but I'm going to autoplay it very fast. And I just want to show you what can happen if you play it in a highly variable environment where perhaps right out of the gate, the concrete contractor was not able to go as fast as possible, right? So this is all just a statistical roll of the dice, right? So the painter in this scenario finished in week 20, 265 people on site with an unused capacity of 97. That's what happens when the early contractors are in a highly variable environment. Let's play a new game, but let's slow down the contractors. So let's say, hey, contractors, let's slow down. I don't want you to run too fast. And let's use your excess capacity as a team to do more planning and preventing. So what that means that you probably won't have 1s. Probably your lowest limit is going to be a 3. Because we've slowed you down as a team, you're also having more consistency, and your slowest pace will increase, meaning you can go faster on the bottom end, but you're going to go slower on the top end. So this is a less variable, this has less variation. It's a more predictable and stable pace. Let's autoplay that and let them go through there as a computer simulation and see what they end up with. And the results are pretty interesting. So when you go through this, you'll see that the painter finished in week 14, 174 people on site with an unused capacity of 6, and the tack plan looked pretty good, right? Actually, this is typically what we experience with our clients. You never get a perfect tack plan, but you do get some variation, and this is typically what we find. We're going to go through a reflection here in just a minute, but here I want to do something interesting. What if we slowed them like way down, like way down, to where they were less than half of their top speed, okay? But because we did that to them, they also were able to up their minimum, and they pretty much could all go the same speed. Now, this isn't realistic in life and on construction projects, but it gives us a really nice perspective. So I want to autoplay this in front of everybody. Okay. Let me just show what that looks like. Let's say we were able to slow them way down, but they're all able to go the exact perfect speed. Not realistic, but it really gives us a good view. We still finished in week 14, 168 people, 0 unused capacity, and this is our perfect takt plan. Like if we could, if we were all robots, if we were all AI, if we lived in a perfect world, this is what we're shooting for, okay? So let's play a new game. Let's hypothetically slow them way, 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 way down to where they're like at 33% of how fast that they could go. The trade partners are mad. They're like, this is garbage. I can't believe you would do this to me. I'm going to walk off the job. But because they're spending that much time planning and preparing, they can go at a consistent speed. Let's see what would happen if we did this just hypothetically, right? They're going at a perfect speed together, but they're going way, way slow, okay? So in this scenario, you'll see that the results end up being that they would finish at week 18 at a pace of 168, or no, a total labor count of 168, 0 unused capacity, and we have that perfect takt line, okay? The reason I'm showing you these scenarios is so that we can do a reflection, and we have this reflection already on the Lean Builder blog, and it's called Takt Towers, Why Pushing Doesn't Work, okay? So in this blog, anytime you explain it to anybody you want to show it to, there's an introduction to the Takt Towers interface, what it means, just like I showed you, how the game actually works, and then we get down here into these scenarios. So the first scenario, we did the dice roll of 1 to 6, a highly variable environment, and the average of playing it from a 1 to 6 is the painter pretty much finishes on week 18. A really solid average is about 238 workers on site with an unused capacity of about 70, and you see this highly variable environment, okay? We typically don't see this with clients. In the takt production system, you typically see something like this with CPM. But this, if I was going to give you an analogy, let's say that the project team has an energy capacity from 1 to 10. And you could spend your energy capacity on problem prevention or just going fast. In this 1 to 6 scenario, this first run, in this highly variable environment, the project team with the trade partners, they were spending most of their energy trying to go fast and very little time problem preventing. And we ended up with finishing on week 18, 238, unused capacity of 70 with a highly variable environment, okay? So that's what we're looking at. When we did the second scenario, where we did the range of 3 to 4, where we said, hey, slow down, everybody. Don't go too fast, but spend your extra capacity making sure that you prevent roadblocks and that your minimum speed can increase. We finished in week 14 with 186 labor, unused capacity of 18. This is typically what we see. This is like a project team spending about 6 energy units going fast and about 4 doing their problem prevention. This is typically what we see with our clients in their takt plans. The reason that we did the third scenario of the 3 to 3, this thing that would never happen, is I want to give you a point of reflection that you would still finish in week 14, 168, 0 unused capacity, perfect takt plan. This would be like, hey, you're not really trying to go fast at all. You're spending most of your energy preventing problems. We wouldn't really sandbag like that, but it's a really nice comparison, which you'll see in a minute. In the fourth scenario, we did 2 to 2. Again, unrealistic, it would never happen. You would never see this perfect scenario. But even if you did, you would finish in week 18 with 168 people on site, 0 unused capacity with a perfect takt plan. This would be like saying, I ain't trying to go fast at all. We're spending most of our energy preventing problems. Now, the reason that I showed all of this to you is when we aggregate the data, we have some pretty neat reflections, okay? All we did in this column here was we said, hey, these are the different dice rolls. These are the weeks. This is the labor total. This is the wage rate. And this is the total cost when you take the sum of the weeks that you're working times the amount of people times the wage rate times 40 hours a week, okay? When you look at this, you see some pretty interesting things. Here are the major reflections for me. When you try and push and go fast and rush, right? This scenario right here, you don't finish any sooner. You have a whole bunch more people on site, and it costs you $6.1 million. The reason I did the 2 to 2 like crazy, slow, unrealistic is because you're still finishing a week 18, but look at your overall total cost, 4.3 million. So you could slow way down and still do better than rushing and pushing. Added labor doesn't do anything for us if you don't have work that the labor can do. They're just standing there. It's not an actual realistic probability. It's not realistic to expect that these 238 people have something to do if you haven't cleared those roadblocks. So when you look at this graph, the 3 to 4, like, hey, let's slow down reasonably so that we can prevent more problems. You finish in week 14, you have a little bit unused labor, right? But you're finishing at 3.7 million, right? And then if you say, hey, what if, Mary Poppins came down and like ran the project, and we were at a 3 to 3, it's still week 14, 168, and it's not much of a difference between this one and this one. So the reflection, once we aggregate the data here, is it does not pay in time to push. It does not pay in dollars to push. If you slowed the project down into an unreasonable rate, it's still more cost effective than if you push. And so what we're asking superintendents to do is to slow down a little bit, spend more time preventing problems. You'll finish sooner. You will have less labor on site, which we need more capacity in our industry, and you will spend less money. It does not pay to push. And so at the end of this blog post, we have this reflection down here at the bottom. So when you have a problem, please remove roadblocks, reduce the effect of constraints, level procurement, keep a consistent rhythm, keep a clean, safe, and organized project, improve your team health, spend more time preparing, increase your training, your communication, do work right the first time and reduce variation. Do not throw labor at the problem, add excess crews, throw money at the problem, rush, go too fast, work unsafely, move up start dates, become frantic, work too much overtime, put people in too many areas, work people beyond their training, and have a lack of breaks and buffers. So the bottom line is, it turns out that the Navy SEALs were right. Slow is smooth and smooth is fast. When we're consistent, we finish sooner and we spend less money. I hope you've enjoyed this video. On we go.